My name is Sam Heiberger for CE 2010 at the University of Virginia, and I'll be running you through my approach to the semester design project. First, there are three project goals. One, to increase pedestrian traffic area by 15%. Two, to provide an ADA compliant pathway from the top of the hill down to the bottom. And three, to improve stormwater management. So I first approached the pedestrian traffic areas, and since they were existing, wanted to expand them first and then design the rest of the solutions around that. As you can see from this polyline here, this outlines the existing pathway before my proposed design. And what I did was, after observation, determine that this was the main route of travel here, and focused my expansion on that. So as you can see from this corridor, increased from the existing, here highlighted in white, 15%, so we will 3 meters across for the duration of this existing pathway. The next goal that I approached was the ADA compliant pathway. There is a hill from the upper left of the design area down to the bottom right, and to cut in a ADA compliant ramp to get to the top to bottom, basically went through some trial and error to find the path of least resistance, which I determined was here, and this kind of contours down adjacent to the existing staircase. And to maintain the 5% grade as the maximum requirement, implemented several horizontal curves to spread out the drop in grade, especially down here at this bottom section. This is particularly challenging, but maintain the grade, and it integrates smoothly with the expanded existing pathway here. So there's a nice flat intersection between these two across that face, and then continues down slope and with a smooth transition at the bottom. The third goal was the stormwater management improvement, and when I did the catchment area assessment, the upper section of the design area channels almost all rainwater down between these trees to a point here at the bottom where it meets an existing underground stormwater sewage system. I decided to utilize this existing natural catchment area, and instead of doing extensive regrading, which would have been expensive and time consuming, implemented 2 bioswale sections to catch that water and help it to naturally filter down into the groundwater, instead of adding to the existing stormwater load. As you can see, there's a bioswale here on the upper right side of the new ADA pathway, and one below it, and new retaining walls to enclose all those in. As you can see, my cut fill came out very low. It was a net cut of 0.52 cubic meters. I was able to attain this by, as I said before, trial and error with the location of this pathway, and again, instead of regrading for additional stormwater management, utilizing the existing ground surface and implementing the bio swales. Again, to highlight the cut fill, you can see here from my proposed profile pathway, most of this cut here at the top ends up going to fill in at the bottom, and also partially goes towards the bioswale infill, although most of that is specialty soils and rock. This is the flattened existing pathway that was expanded by 15%. And again, that this would be this left side of the profile corresponds to the bottom section of this pathway. So as you can see, I've flattened that out as well to reduce the speed of the runoff from stormwater. So that is my design solution. Again, a low cut fill, addressed all three project goals, and kept the budget and time constraints to a minimum. Thank you very much.